Today we're going to go over theoretical and experimental probability, and I want you to be able to find the theoretical and experimental probability of an event. So let's talk about what each one of those are. First we need to talk about probability. Probability is the measure of how likely an event will occur. And the outcome is each possible result of a probability experiment. Sample space is the set of all possible outcomes. Now, an event is an outcome or a set of outcomes. When you're talking about theoretical probability, that means in theory what should happen. So let's say that you tossed a coin in the air and you wanted to know what the probability is that you would get heads. The probability would be 1/2 or 50%. Now, if you actually conducted an experiment, most likely you would not get a result of 50%. So theoretically, again, theoretical probability means what should happen. So the number of favorable outcomes over the number of outcomes in the sample space or your trial. So another way you can think of it is what you want to happen over the total possible trials that you have. So let's look at this example. Each letter of the word probable is written on a separate card. Now, probable has 7 letters and it has 5 consonants. And the reason why we're doing that is because the cards are placed face down and mixed up. We want to know the probability that a randomly selected card has a consonant. So we take the total number, what we want, and put it over what we want to happen. So the total number would be 7. What we want is to get a consonant, and there are only 1, 2, 3, 4, 5 of them. So what we want to happen, there would be 5 things, 5 consonants, that's what we want to happen, over 7. So that would be 5/7, and we can also write that as a percentage, 62.5. Now sometimes you'll need to find the complement of an event. So all the items in the sample space that are not in the event. And we're going to change this one a little bit to match up the problem a little bit better. So we have the game Battleship, and it's played with 5 ships on a 100-hole grid. Players try to guess the locations of their opponent's ships and sink them. At the start of the game, what is the probability that the first shot misses all of the targets? Well, let's, instead of numbering these game pieces, let's put what they are. We have a destroyer, we have a cruiser, we have a submarine, we have a battleship, and then we need to also add the carrier. Okay, so the number of holes that each one of these cover would be, the destroyer is going to cover 2 holes, the cruiser 3, the submarine 3, the battleship is 4, and the biggest one is the carrier, which would be cover 5 spaces. So at the beginning of the game, we want to know our first guess, what's the probability that the first shot misses all of the targets? Well, what we can do is we can add up all of the numbers that would actually mean we would hit a target. So that total would be 17. We want to know what's the probability that we're going to miss. So we know there are 100 total, and there's 2 different ways you can do this. You can either say, okay, well, we could take 1 and subtract 17 over 100, because that's the total number of holes there are, and 17 would be the possible hit. So we could say, okay, we're going to take 1 and subtract 17 over 100, because we want to know misses. This is possible hits. So that would give us 83 over 100, or 83%. Second way you could think about it is just, if we know that we have 17 possible hits, that means 100 minus 17 would give us 83 misses. So we could just do 83 over 100. So either way, so 83 over 100, both ways. So you want to be really careful when you're reading probability, because sometimes a not will be thrown in there, N-O-T, and it's just a small word, but it sets up the problem differently. Okay, finding probability with permutations or combinations. We have here that a student receives a 5-digit locker combination. We want to know what the probability of receiving a combination with all odd digits. Okay, now when you see the word probability, you want to think want over the total. So you want to set it up like a fraction. So that means what we want to happen is we want to have a 5-digit locker com with all odd digits. That will be our numerator. And then the denominator would be how many ways can you choose just a regular 5-digit locker combination. So what we want to happen, how many odd digits do we have? Well, we have 1, 3, 5, 7, and 9, and we have 5 digits. So we need 5 blanks, and then we're going to put in, now it doesn't say anything about that they can't repeat. In locker combinations, they can repeat. So we're just going to put, okay, 1, 3, 5, 7, 9. That would be 5 for each one. And if we multiply those all together, we're going to get 3,125. And because this is probability, we need to put what we want to happen over the total that could happen. So the total that could happen, we have 5 spaces again, but now we have those 9 digits. So that would be 10, 10, 10, 10, 10. If we multiply the numerator together, we're going to get, or numerator, all the 5s together, we're going to get 3,125. Multiply the denominator together, all the numbers in the denominator, I should say, and we're going to get 100,000. So that's going to reduce down to 1 over 32. That would be the probability that you would have a locker combination with all odd digits. Okay, now we're going to do geometric probability, and you did this last year. So a dart is randomly thrown at a dartboard, and what's the probability that it lands in the outer ring? So if it can only hit the dartboard, what's the probability it's going to land right here? So we want to know the space right here. Well, in order to do that, we need to know the probability of the entire area, and we also need to know the area of the outer ring where we want it to land. So let's figure out the entire circle. That's easy enough to do. We know the area of a circle is pi r squared. So we're going to take pi, and here the radius, we know from here to here it's 2 inches. From here to here it's 1 inch. So our radius for the entire circle is going to be 3. So we need to do pi times 3 squared. And now we need the outer circle. Well, in order to find the outer circle, what we need to do is have the whole circle, and then we need to take this part out of it because we don't want that inner circle. So we already know the area of the entire circle, and we need to subtract the inner circle. So the entire circle, again, is pi r squared, which is just going to be 9 pi. And if we go to the inner circle here, we know that the radius is 1 inch. So that's going to be pi times 1 squared, which that will just give us 1 pi. And then we're taking out the inner circle because we just want the outer circle. So we just need to subtract those two, and that's going to give us 8 pi. Okay, so that is where we want it to land. So 8 pi is where we want it to land. The entire circle, again, is 9 pi. So we're just going to put where we want it to land over the total, and the pi's will just reduce. So we have the probability that it's going to land in the outer circle is going to be 8 over 9. And again, you could change that to a percent if you wanted to. All right, we are going to cross part of this off here. Experimental probability is the actual number of times, I'll just cross this off here, number of times an event occurs to the number of trials. So experiment is when you actually flip the coin and you record how many heads versus tails you have, where theoretical probability is you just say, okay, probability that I'm going to toss a tail would be 50% or 1 out of 2. We're going to cross this off and go down to the example here. So we have an experiment which was actually conducted, and our results are over here. And we want to know, we want to find the experimental probability. And again, when you see probability, put want over total. So what we want to happen, let's say that we want to know the probability that you're going to spin a 4. Now this spinner is evenly divided, so we have 1, 2, 3, 4. When you actually conduct the experiment, you don't have 25 in each one, which would be the theoretical probability, because in theory that's what should happen if the spinner is evenly divided. So what we need to do is we need to know the total occurrences, and that trial had 50 spins. We want to know the probability of spinning a 4. Well, spinning a 4 came 14 times. So the experimental probability where we want it to land would be on a 4, so that would be 14. Total number would be 50, so want would be 14, total would be 50. And then we can just reduce to 7 over 25, or that's going to give us 28%. Okay, now you have a few problems to try.